Hi, my name is Dima, and in today's mini exam video, we'll be going over DNA mutations. First, let's look at this DNA sequence in vivo. We have to find out which strand is the coding strand for transcription and translation. We want to look for one with a protein that is 5 amino acids long. Let's figure out where the start and the stop codons are for each. If we look at this top one, we find a start codon here and a stop codon here. But if we count 1, 2, 3, 4, this only gives us 4 amino acids. Therefore, this is going to be non-functional, or not the one that we're looking for. If we look at this bottom one right here, we see a start codon here and a stop one right here. And this would give us 5 amino acids. Therefore, this is going to be functional. The top strand is going to be our template strand, while the bottom strand is going to be our coding strand. The coding strand will provide the mRNA strand, and both will be going from the 5' to 3' direction. This sequence encodes and translates into the following amino acids. Now let's talk about mutations. First, we have missense mutation. For this example, we're going to be changing the G to a C, and this is going to be transversion. Once we change this, it's going to change what was originally over here, which was valine, into leucine. This just changes the amino acid. It could alter the protein function or make the protein non-functional. Next, we have nonsense mutation. We're going to be changing the A to a T, which is going to be transversion. Once we do this, what was originally here, which was the lysine, is going to convert into a stop codon. This changes the codon to a stop codon. It could pause the amino acid sequence, causing it not to completely translate. It doesn't encode for ideal functional proteins. Next, we have silent mutation. For this specific example, we're going to be changing the C to a T, which is transition. After we changed it, it's still coded for phenylene. The UUU and the UUC, which was previously here, both code for phenylalanine. Since they both code for the same amino acid, the protein remains functional since there wasn't really much change in the function of the protein. Next, we have read-through. If we change the T to a C, which is transition, it's going to remove the stop codon, and instead we're going to have glutamine. This is going to keep going until you get a stop codon. The stop codon changed to amino acid codon, resulting into a longer change, and this can be a non-functional protein. Here are all the mutations all on one slide, and here are my references. Thank you for watching this video.